All right, so we want to derive this equation over here and find the derivation at the point 1, comma 1. So we got to do implicit derivation here because the x and y's are all mixed and you cannot isolate y. I'm going to start by deriving this first term here. I have two terms here, so I'm going to derive by product rule. So f equals to x cubed, g equals to y. F prime is just 3x squared, and g prime, the derivation of y is just 1. And then anytime you derive a y term, you have to multiply by y prime. That's your implicit derivation. So 1 times y prime is just y prime. So now I can put this in my product rule, which is f prime times g. So that's just 3x squared y plus g prime times f. G prime times f is just x cubed y prime. Next, I want to derive this term over here, which is also going to be with product rule again, because I have two terms. So f equals negative 3x, g equals to y squared. F prime is just negative 3. G prime is the derivation of y squared is 2y and then times y prime. So now I can combine this over here. F prime times g is negative 3y squared plus g prime times f. So negative 3 times negative 2 is negative 6. And then I have x and then y and then y prime. Can go to the next term here. The derivation of 4x is just plus 4, and the derivation of negative y is just negative y prime. The derivation of 1 is just 0. Now I can just sub in my point and then isolate y prime. So if I sub in my point 1, 1 here, this is just going to be 3. This is just going to be y prime. This is just going to be minus 3. 3 times 1. This is just going to be minus 6y prime. This is just going to be plus 4, and then minus y prime equals to 0. I can combine my like terms. 3 minus 3 is 0. So I'm just left with a 4 here. And then y prime minus y prime is 0. So I just have negative 6y prime, because these two cancel and these two cancel. So I have negative 6y prime plus 4 equals to 0. Negative 6y prime equals to negative 4, and then I divide both sides by negative 6. So I get the derivation to just be 2 over 3. Negative 4 over 6 can be simplified to 2 over 3.